Hi everybody, this is lesson 2.2, counting our votes. Let's look at the specific objectives. So in this lesson, we'll understand that the concept of proportional representation in voting, how representation in the US Congress is allocated, and students will be able to calculate a unit rate, solve a proportion by finding a unit rate, and then multiply appropriately. So as you can see, we're going to be talking about United States Congress today and doing some mathematics, which has to do with voting. Interesting. Alrighty, so the first question that I would like to ask you is, can you tell me what do you know about United States Congress? So can you take a moment and write a few sentences describing what you know about United States Congress? Alrighty, so let's read the first problem situation. Voting for the House of Representatives. So the United States Congress consists of two bodies, the Senate and the House of Representatives. For legislation to be enacted, it must pass in both of these bodies. The House of Representatives consists of a fixed number of 435 voting representatives. These representatives are all allocated to each state proportionally. I'm going to even highlight that term because that's what we're going to be looking at in this lesson. And it's allocated based on population. Recall that ratio and other quantities are proportional if there is a relationship between a number that is always the same. In other words, this means that the higher a state's population, the more representatives it will have. The aim of this method of allocation is for the United States voters to have relative equal representation in the House. Each state might have at least one representative. Alrighty, so I would like for you to find a representative for your area where you live. And each of us has a person who represents us in the House of Representatives. There are 435 people in the House. That number had mostly remained unchanged since the beginning of the 20th century, but the concept that each person in the United States has a representation is important. So go ahead, can you Google and find who your representative is and write the name of that person in the appropriate place. Alrighty. Here's I pull up the website house.gov, which is the official website for the House of Representatives, which is a branch of Congress. I'm going to put my zip code, 11235, and I'm going to look to see what my representatives are. So here they are, all right? So it's a New York, these are the ones that representing me and people in that zip code based on the geographic location. Alrighty, so if I press on the person, they will give me the information where they work, how to reach them, find out who they are, and these are the people who basically representing us. So get to know your representative. All right, so let's talk about mathematics behind this idea of representation. So question number one, representatives were last allocated in 2010. It's a little outdated statistics. Actually, the last allocation has happened later, I believe in the year 2020. But for this lesson, in order to understand the mathematics of it, we're going to use the numbers from 2010. As you know, last year the census was conducted to find out information about people living in the United States. So that's at exactly the same time then this type of mathematics that you're going to be doing is done. All right, soon we will update this lesson to reflect the 2020 census. Well, we're going to look at 2010 census, and that year there were 309 million people living in the United States. So the question is asking us to find the average number of people represented by a single US representative in 2010. Write your answer as a ratio in a fraction form. So look at the language. It says number of people represented by US representatives. So we can write this out as people per 1 representative. Okay. So let me give you a moment to calculate that ratio. Alrighty, so let's go over it. So the number of people in the United States in 2010 was, so I'm going to first write this as a ratio, people divided by representatives, reps, I'll just abbreviate it like that. I'm going to write the number 309 million. I'm going to write that in the standard form. And I'm going to divide this by the number of representatives that there are in the House, and that number is 435. Okay, I'll abbreviate people per representatives. So when you do the division, the 435 will get distributed evenly among the entire population of the United States, and then we'll get that rate. Okay, so 309 million, 123, divided by 435. So we get 710,344 people. I'm gonna like 0.8. Let me round it like this. People per representative. I just rounded to the nearest tenth. It's better to keep the number in the memory of your calculator for any future calculation. So to give you this into perspective, this number is about the size of maybe state on island. We did the lesson prior to this talking about the sizes of each. We talk about densities of each borough of New York City, and state on island is about that population, slightly higher. So imagine that you have this whole, population of that of state and island is represented by one person. It's not exactly by like states. It's based on the zip codes. So when the allocation is done, it has to do with the geographic location. Well, it is within the state. Let me just bring it back. It is within the state, but the particular zip code are chosen, so you have about that representation. You understand? So, and then when the election comes in, people in that area that has about 710,000 people go to the election site and they choose their representative. Our next election will happen in the year 2022. All right, so the elections in the House goes in a cycle every 2 years. The same for the Senate. Not every single representative goes for the re-election, but there is a cycle that happens for each person, and they get voted for. Okay, no one is chosen for eternity. All right, so now look, we're going to use that number. Understand that this number of people are represented by one representative. Now we're going to look at 3 states: Ohio, Wyoming, and California. So California is the largest state in the United States. Wyoming is, I think, one of the smallest, maybe the smallest state. It has a less population than the population of state on island. And you also have Ohio, which is, it's a large state, not the largest one, not the smallest one, so it's somewhere in the middle. And we're going to go ahead and allocate. Allocate means find how many representatives that does each state needs to have. So according to the idea of this proportionality is that this number has to stay the same regardless of where the person lives. So if you think about 710,345 people about per one representative, Ohio has more than that. It has 11 million and something. So then how many representatives should Ohio have? Think about it for a moment and see if you can do the calculation. Alrighty, now let's go ahead and review. So look, if there are 710,000 per one, 2 of them will be 710,000 multiplied by 2, multiplied by 3, multiplied by 4. So the question is, what will 710,344.8 needs to be multiplied so we get the population of Ohio? And of course, if you look at this type of question, then you kind of see that in order to find this, you want to know how many times does this number go inside that number. into the population. So we're going to take the population of Ohio, and we're going to divide it by the population, by the representation rate. This is called rate of representation. Okay, that's how many people per rep. So we're going to take the population and we divide by representation. So that would be 11,568,000 people divided by 710,344.8 people per one representative, and our answer would be how many representatives we got. All right, so I'm going to take my calculator and I'll divide 11,568,000. All right, and I'm going to divide this by 710,344.8, and I'm going to get an answer of 16.29. All right, now, of course, we cannot have 16.29. Let me write it here so you can see it clearly. That cannot be the number of representatives, right? Because that's a decimal. So now let me ask you, if you were to round this, would you choose 16? Would you choose 17? What should it be? All right, so I'll give you a moment. So would you choose 16 or would you choose 17? All right, so if you think about this, 16.29 means that there are enough people in Ohio to fit 16 representatives. And that decimal piece, 0.29, is not enough. It means it has more than what 16 times the representation rate would give you. But those extra people that we have is not enough to make it for another representative. So in this case, mathematically, it also rounds to 16, right? Using regular rules of rounding. But keep in mind, just make a note for yourself. Even if the result rounds up mathematically, you still round your answer down. You still round your answer down. So what that means, if you divide, let's say, just hypothetically, if you divide and you get the result like 16.9, even though mathematically it rounds up to 17, you're still going to round it to 16 because 0.9 is not sufficient to make it a full representative. You need more people to make it 17. You see what I'm saying? So when you're doing this calculation, and you will be asked to do this, whatever answer you get, just get rid of that decimal. Don't round it mathematically. Just get rid of that decimal and always round it down regardless. So the answer would be 16. All right, so now I'll give you a moment and calculate this for Wyoming. How many representatives should Wyoming get? All right, let's review. Well, this is a little trickier because Wyoming has less than the representation rate, right? So if you divide it by, what is it called? 710,344.8. You're going to get a number less than 1. And I just told you that you should be rounding always down. So Wyoming should get no representation. Well, the founders who wrote the Constitution, and by the way, this idea of allocation was written in the Constitution when it was drafted in the 18th century, right? So that clause was thought of. So if you have a state that has less than people, then mathematically gives you at least one representative, then you give that state at least one person. Okay, so even though this one rounds down, well, it goes to 0 because it's not enough for one person, this state will still get one representative. Each state has to have at least one representative regardless of the size of the population. Okay, so if math doesn't give you an answer, it gives you 0, you give that state one representative still. Well, California has much more than 700,000 people. It has 37 million. So go ahead and take a moment and calculate the how many representatives would California get, and then we'll review. All right, so let's divide 37,342,000 people, and we're going to divide by the representation rate. Let's see what we get. So 37,342,000 divided by 710, 348, 344.8. So that's about 52.56 something. Well, that's a perfect example where this thing rounds up mathematically to 53, but because again, this is not enough to make it a full representative. You don't have enough population. You see what I'm saying? If you round it up, that means you are assuming that you're using more people, but that's not the case. So once again, the idea of rounding is that you're always going to round it down, and that's not a mathematical rounding. It's a contextual rounding based on this understanding of this allocation. All right, if you don't have enough for one person, for a full person, you just disregard that decimal. There's much more. There are courses in mathematics that deal with the theory of voting. And in the United States history, there are about 4 or 5 methods of allocation. And the very last one, the one that is used right now, is a variation of this mathematics, but it's not exactly that. There is a little caveat of what to do with these leftover decimals. All right, so if you would like to learn about it, you can Google theory of voting and see what mathematics goes into it. It's quite interesting. But for us, for the purposes of this class, what we want to understand is that this number right here, 710,348, this right here, sometimes it's called a cookie cutter. Like it takes some, when you cooking, you're making dough and then you do a little forms and you create a little cookies. So 710,344 is like a cookie cutter where you get this cut inside whatever the population is, and you see, how many cookies can you get? Full cookies. So if you have any leftovers, you just disregard them. So that's kind of, you can think about that way. So this right here, that's a cookie cutter, which is the rate of representation. Alrighty. Okay, so that's an essence of the lesson. Now, let's expand this a little bit. So, this is kind of interesting because this lesson is quite outdated with the numbers. It says that in 2020, the population of the United States is expected to grow to 333,196,000. I'm just curious to see what it was actually last year. So population of the US in 2020 was 331.4 million. Look at that. It's pretty close, right? So it's a little overestimate, but it's not much off from the reality. So that's kind of cool, which is, by the way, also a mathematical idea of how you predict what's going to happen in future, which we also will discuss in this class during our last chapter. Alrighty, but for now, again, we're going to use the numbers that are given in this question in order to do the, to answer the question. So here's what they ask us to do. If the population in 2020, we're going to assume to be 333,896,000. All right, we're going to look at Ohio. We assume that the population remain the same, and quite interesting that population of Ohio did indeed not increase much. So look, it's 11,568,000. You can look it up to see if it's really remained the same. But again, we're going to use the numbers that are in this lesson. So figure it out. I'm going to give you a moment. The number for the cookie cutter. So what would be this rate of allocation? So calculate the rate first. All right. And then we're going to use that rate to find what would be the number of representatives. Will it stay the same? Will it decrease? Will it increase? All right. Let me give you a moment to calculate the rate of allocation. Let's review it. So once again, how do you do the rate of allocation? You take population of the entire United States, not Ohio. So you take the entire population of the United States and you're going to divide it by the representatives that there are in the House. And that number does not change. It still stays as 435 representatives. So we're going to take the population, 896, and we're going to divide it by 435 representative. So our cookie cutter is going to increase because the population goes up. All right, so let's see what is our cookie cutter now. It's bigger. So I'm dividing by 435. So now we're getting 767,000 and 710,000. You see it grew because the population grew. And conveniently, it's like 0.0, so we can leave it like that. So it's people per representatives. And now go ahead and use that cookie cutter to allocate the representation for the state of Ohio. I'll give you a moment. And make sure that you also round it correctly, okay, at the end. Remember, it is contextual rounding rather than mathematical rounding. All right, let's go ahead and review. So we're going to have 11,568,000, and we're going to divide by this allocation rate. And let's see what's going to happen to the population. So 11,568,000 divided by the cookie cutter, 767,577, and now the population, the allocation actually goes down. You see, it becomes 15.07 instead of 16 something. All right, and now when you're rounding here, you just truncate it. So it's going to be 15 representation. So Ohio lost projected to lose 1 representative. All right, go ahead and Google and find out what happened to Ohio. Did it actually lose? And that actually, yeah, the allocation happened last year. So you can see which state gained and which state lost. All right. And what's interesting is that, you know, states like New York, California did lose some representation, or the representation remained the same, while some states in the South, Texas, Florida, has gained, but not as significantly as it was predicted. Alrighty, so that's the allocation idea. You see how the mathematics is used in voting? So here it goes. Alright, the problem says situation number 2 is talking about the Senate. So in the Senate, things are much more straightforward. Okay? The United States is allocated differently than the House of Representatives according to the U.S. Constitution. Each state, regardless of their size, will get 2 senators, including the poor state of Wyoming. And poor in a way that it is, you know, not as large. That's what I'm saying, is that it doesn't get that many representation in the U.S. House, but in the Senate, it is getting 2 senators, regardless of their size. All right, since there are 50 states, the U.S. overall is represented by 100 senators, okay? And the way the voting is done in the Senate, you have, when, you know, this is not a political science course, but the way that laws are enacted in the United States, they can originate in the House or they can originate in the Senate. But then once one chamber votes for something, the other chamber has to approve it. So in the Senate, there are 100 senators, and also the vice president also has a vote in case of the tie break. Okay, so that's something that, you know, I'm hoping also hearing on the news and kind of being aware of how the things are running in the United States. Okay, so there are 100 senators, and each state gets 2. And here's the question there, is based on your understanding what you just read. Are states represented in the Senate in a way that is proportional to their population? In other words, does it matter whether the population is large or small? Does it matter how many representatives should it have? Just answer that question. Well, of course it doesn't. It doesn't matter. So the answer, are states proportional? The answer is no. Each gets 2 people. That's it. So when you look at the representation rate, just like we did in the other question, It's asking us find a number of people represented by a single senator in the following state. So in Ohio, for example, there were, again, we're using 2010 numbers. Ohio had I have it written right here instead of me going back and forth. I have printed out the lesson. So Ohio has a population, had, I keep saying had, we're looking at the year 2010. So it had how many people? It had 11,568,000, and it's represented by 2 people equally, right? So practically speaking, then 10 million is get allocated for each senator. Kind of, you can think of it like that. Yeah, they're representing that state simultaneously. They're working together. But the idea is if you want to write that as a representation rate, then you just take that number and divide it by 2. And you do the same thing with all the other states. And we're doing it so then we can kind of answer the last question of that lesson. And what does it mean from the perspective of the voter? So for now, let's just go ahead and write those numbers. So one representative is representing about 5.8 million people. In Wyoming, that number is much smaller. So Wyoming has 568,000 people. You divide that by 2 people. So one senator represents much smaller amount of people, which is 284,000 people per one representative. One. And California is the largest state, is going to have the highest rate per one, because it's still dividing it by 2, you see? So if you take 37,342,000 and you're dividing it by 2, you're getting 18,671,000 people are represented by one person. So now the question is, which is the last question in this lesson that we'll address, I'm not going to go into problem station number 3. It's asking us, compare the relative voting power with respect to the Senate of the person in California versus a person in Wyoming. So first question is, it says, do the residents of California and Wyoming have the same influence in the state Senate representation? If not, which voter has more influence and by how many times? Write your answer as a sentence using clear and specific language. So first, I would like for us to choose which person in which state has more access to their senator. In other words, whose vote will influence the senator more? A person in California or a person in Wyoming? Choose one. The right answer would be Wyoming. Why? Because there are less number of people that are represented by that one representative. So theoretically speaking, these people are the ones who are electing senator, have more power in terms of choosing that person, because that person from Wyoming, the senator from Wyoming, has the same strength in terms of their vote as a person from California, the representative from California. They are the same power because there are 100 senators. Each state has 2, regardless of their size. So in another way, the Wyoming, people in Wyoming has, because it's smaller population, of higher access to their representative, and in a way, their influence is mathematically stronger. By how much? Well, that's something that we can do by sort of invoking the things that we used in the first modulus. We want to see how many times is this number more than that number. How many times more? The word times, that means you have to set the ratio of the larger number to the smaller number. So we're going to take California divided by Wyoming, and we're going to get 18,671,000 people per representative divided by 284,000 people per representative. And once we divide those numbers, we're going to see, notice that California has a larger number on top, but it doesn't mean that they have a stronger representation. Let's get rid of this. So 18,671 divided by 284 So the rate in California is 65.7 times as influential. The rate is that. Well, the rate is 65.7 times the other rate. So then we say that a person in Wyoming has 65.7 times influence on their senator compared to a person in California. Don't get confused here. The rate for California is higher. It doesn't mean that the people in California have a more access. It's the other way around. Because the rate is higher in California, that means that their influence is lower because there are many more people that are represented by that one representative. And on that, we're going to finish this lesson.